Okay, in this video, we're going to talk about section 6-3, dealing with multiplication, division, and estimation with rational numbers. In this video, we'll talk about how to multiply and divide rational numbers, recognize properties of multiplication and division of rational numbers, estimate through the use of multiplication and division of rational numbers, and extend the use of exponents to include negative integers. All right, so to motivate this section, dealing with the definition of multiplication of rational numbers, we're going to start with the interpretation of multiplication as repeated addition. Okay, because those two operations go hand in hand. Multiplication, which is, of course, taking some number, adding it in number of times, because it is repeated addition. So like 3 times 3/4. That's the same as taking 3/4 and adding it 3 times. So 3/4 plus another 3/4 and another 3/4 ends up being 9/4. Now, 9/4 is this. We got 2 wholes with 1/4 left over. So it'll be 2 1/4 for 3 times 3/4. Now, multiplication as a part of an area is another model for multiplying rational numbers, like, let's say 3/5 times 1/2. We start off with 3/5. So here we got a rectangle divided equally into 5 parts. 3 of those parts are shaded, so that's 3/5. And then let's say 1/2, we go across and split this halfway. So each piece that you see here represents 1/2 going this way. So if we combine those, you'll get 1/2 times 3/5. And in this case, the final answer there will be 3/10. So this is what 3/5 times 1/2 would be. 3/10. Okay. Now let's look at the definition of multiplication of rational numbers. If A over B and C over D are any rational numbers, then A over B times C over D will be equal to this. We multiply the numerators, A and C, over multiplying the denominators, B and D. So it'll be A times C over B times D for multiplication of rational numbers. Okay, here's a couple of examples here. Let's find each of the following products and write the answers in simplest form. Okay, so in part A, I got 36 over 80 times 96. 36 over 96 times 80 over 108. 36 over 96 times 80 over 108. Now, there are pretty much a couple of ways you can multiply this out. You can multiply numerator times numerator, and then denominator times denominator, and then you're going to have to find a number, the largest number that goes into both the numerator and the denominator. Or we can do cross dividing with numbers like 96 and 80, and also 36 and 108. For me, it would be easier to do cross dividing, because I can look at that 36 and 108 and find a number that goes into 36 and 108, and that's going to be the 36. Okay, so here 36 goes into itself 1 time. Then 36 goes into 108 3 times. Now for 80 and 96, the largest number that goes into 80 and 96 will have to be 8. And it might be a number larger than that. But for now, we'll just use 8. 8 goes into 80 10 times. and 8 goes into 96 12 times. So I'll end up with 1 times 10, which is 10, over 12 times 3, which is 36. But here I can reduce 10 over 36 in simplest form by dividing the numerator and the denominator by 2. So here, 2 goes into 10 5 times, and 2 goes into 36, 18 times. So 5/18 would be the answer to that problem in simplest form. Okay. Now, again, you can multiply numerator times numerator and then denominator times denominator, but you're just going to have to keep reducing until it is reduced in simplest form. All right, part B. Here we got Q over Y times Y squared is equal to Q squared. Okay. Now you could do this. Since we're dealing with variables here, we can still cross divide just like we did in part A. Okay, like with the Y and the Y squared, there is a Y in Y squared, which can be divided out with this Y. So this Y divides out with one of the Y's in Y squared. I'll be left with a Y. And with Q and Q squared, this Q can be divided out with the Q squared. With one of the Q's in Q squared, you'll be left with a Q. So final answer there will be Y over Q. And part C, D over N, dN over M, dN over M times M squared B over D cubed N squared. And in this case here, we can do cross dividing here as well. One of the D, this D will divide up with one of the D's in D cubed, leaving you with D squared. And one of the M's, this M will divide out with one of the M's in M squared, leaving you with an M. And then this N divides out with one of the N's in N squared, leaving you with an N. So what's going to be left in the numerator will be this, M times V or MV. The denominator will be left with D squared times N. So it'll be MV over D squared N. Okay. All right, now let's look at some of the properties of multiplication of rational numbers. Multiplication of rational numbers have properties analogous to the properties of multiplication of integers. These include the following properties for multiplication: closure, commutative, associative, and multiplicative identity. Now, when we expand from the set of integers to the set of rationals, we pick up an additional property, that is the multiplicative inverse property. All right, so here I got the inverse, well, the identity and the inverse properties of rational numbers. We'll look at those. Starting with the multiplicative identity. The number 1 is the unique number such that for every rational number A over B, 1 times A over B, or A over B times 1 would be A over B. And then we have the multiplicative inverse, which is another way of saying the reciprocal. And that's this: for any non-zero rational number, A over B times B over A is the unique rational number such that A over B times B over A is equal to 1, or B over A times A over B is equal to 1. So pretty much when you're finding the multiplicative inverse, you're finding the reciprocal by flipping the numerator and the denominator in their different positions. In other words, the numerator becomes your denominator, the denominator becomes your numerator. So like in these examples here, let's say I want to find the multiplicative inverse of each of the following. So in part A, I got -1 over 7. So all we do there is just flip this fraction over. It'll be 7 over -1. And 7 over -1 would just be -7. Now for a mixed number like 1 2/5, we don't flip the 2/5 over because we got that 1 in front. We need to convert 1 2/5 to an improper fraction, and then we take the reciprocal. So 1 2/5 as an improper fraction is this. 5 times 1 will be 5, plus the 2 will be 7 over 5. And then we take the reciprocal, or the multiplicative inverse of 7/5, which will be 5 over 7. Now part C, we got y over z, and the restriction here is y is not equal to 0. Well, if y is not equal to 0, we can take the reciprocal of y over z. So it'll be z over y. That's all there is to it. And then for part D, -6. Well, if I write -6 as -6 over 1, then we can take the multiplicative inverse of that, and that will be -1/6. Okay, that's how we take the multiplicative inverse or the reciprocal of rational numbers. Okay. Next, we'll look at the distributive properties of multiplication over addition and subtraction of real numbers. And it's going to be this: if A over B, C over D, and E over F are any rational numbers, then, then A over B times the quantity C over D plus E over F is equal to, it would distribute the A over B over the C over D plus E over F through multiplication. So it'd be A over B times C over D plus A over B times E over F. And the same holds true for subtraction here. If this was subtraction, we can distribute what's on the outside, the A over B over C over D minus E over F by multiplication. So it'd be A over B times C over D minus A over B times E over F. Okay. All right, next we'll look at the multiplication property of equality for rational numbers. All right, so if I let A over B, C over D, and E over F be any rational number such that A over B is equal to C over D, then that means I can multiply E over F on both sides and get a true equality. Okay. Now, next we're going to look at the multiplication property of inequality. If you recall, inequalities have either less than, greater than, less than or equal to, or greater than or equal to, and also not equal to. Those are inequalities here. So if A over B, C over D, and E over F are any rational numbers, and that means this: if A over B is greater than C over D, as long as E over F is positive, that means greater than 0, I can multiply E over F on both sides of the inequality, and the inequality symbol will not be changed. Now, on the other hand, let's say E over F was less than 0. That means E over F is negative. And if I multiply both sides of the inequality by E over F and it's negative, that means your inequality symbol will change from greater than to less than. Okay. So if you multiply or divide both sides of an inequality by a negative number, your inequality symbol reverses to the opposite direction. Same holds true for rational numbers. All right, on the next page is the multiplication property of 0 for rational numbers. If A over B is any rational number, then A over B multiplied by 0 or 0 multiplied by A over B is going to be 0. So any rational number multiplied by 0 is 0. Okay. So now let's look at an example here dealing with multiplication. And it says here, excuse me, 5/9 of the students at a nearby college live in dormitories. If 5,000 students at the college live in dormitories, how many students are there in college? Okay. So we need to find out how many students are there in college. So I'm going to let some number S be the number of students in college. And we're told 5/9 of the students, well, 5/9, we write that as 5 over 9 of the students, that's multiplication, and that's S. That will be equal to the number of students that live in college dormitories, because it says 5/9 of the students at a nearby college live in dormitories. And we know that 5,000 students at the college live in dormitories. So it'll be 5/9 S equaling to 5,000. Okay. Now to solve this equation, you would normally divide both sides by 5/9. But what is the reciprocal of 5 over 9? Let's use 9/5. So here we're going to multiply both sides of this equation by the reciprocal of 5/9, which is 9/5. And I'm going to put the 5,000 over 1. And the reason why I'm doing that, because what's going to happen here is the 9s divide out and the 5s divide out. You're left with just S. So the S is equal to, now we're going to do 5,000 over 1 times 9/5. And you probably can see from here that 5 goes into itself 1 time, and 5 goes into 5,000 1,000 times. So if I multiply 1,000 times 9, that will be 9,000 over 1 times 1, which is 1. And of course, 9,000 divided by 1 would be 9,000. So to answer that question, 9,000 students attend college. Okay, so that's how we solve that problem there. Okay, take a look at homework example number 4. A dress is on sale for $90. What was the original price of the dress if the discount was 1/3 of the original price? and it was on sale for $80. I'm sorry, for $90. Okay. So now we're going to find the original price. So I'm going to let, well, we're dealing with the dress, let's say D, be the original price of the dress. Now the discount was 1/3 of the original price. So it's going to be 1/3 times D, and that's going to be equal to the sale price of $90. So we got 1/3 is equal to 1/3 D is equal to 90. Now we want to find out what D is. Well, normally we would divide by 1/3, but it'd be easier to take the reciprocal of 1/3, which is going to be just flipping the fraction over 3/1. So it'd be 3/1 times 1/3 D equaling to 90 times 3/1. And I'll go ahead and put the 90/1. It's not necessary. Here the 3's divide out. 1/1 times D would just be D. 90 times 3 will be 270 over 1 times 1, which is 1. Well, 270 divided by 1 would be 270. So the original price of the dress was $270. Okay. All right, on the next page, this deals with multiplication of mixed numbers. Multiplication of mixed numbers. One way to multiply mixed numbers is to change the mixed numbers to improper fractions and use the definition of multiplication. Another way is to use the distributive property of multiplication over addition. Okay. Now, in this example, we're going to do this in 2 ways. Multiply 2.5 times 2.5 using improper fractions and by using the distributive property. Okay, so method 1 is just using improper fractions. So if I have 2.5 times 2.5, I'll convert those to mix to improper fraction and then multiply. So for 2.5 will be 2 times 2, which is 4, plus the 1 will be 5. So it'll be 5 halves times 5 halves. And then do numerator times numerator over denominator times denominator. 5 times 5, that's 25, over 2 times 2, which is 4. So you have 25 fourths, and if we convert that to a mixed number, 4 goes into 25 6 times with 1 left over. So it'll be 6 1/4 as the answer. Now, method 2, we're going to take 2.5 times 2.5 and use the distributive property. Now, the way we're going to do that is this. I'm going to break 2.5 as 2 plus a half, and 2.5, same thing, 2 plus a half. Now, if we use the distributive property, let's think about this. This 2 plus 1/2 will be multiplied by 2. So I'll take 2 plus 1/2, that'd be multiplied by that 2, plus that same 2 plus 1/2 will be multiplied by this time 1/2. This multiplied by the 2, this multiplied by the 1/2. That's the distributive property. And then I'm going to use the distributive property again. In other words, this 2 on the outside would be distributed over the 2 and the 1/2 through multiplication. So it'll be 2 times 2, which is 4, plus 2 times a half. Well, 1/2 of 2 is 1. And then plus, this 1/2 will be distributed over the 2 and the 1/2 by multiplying. So if I do 1/2 of 2, that's also 1. 1/2 times 1/2. 1 times 1 will be 1 over 2 times 2, which is 4. Now, if we add 4 plus 1 plus 1, that would be 6. And then I got 1/4 to put next to it. So 2.5 times 2.5, well, we give you 6 1/4. Okay. Here I used the distributive property and came up with that same answer as I did when I converted 2.5 to improper fractions and multiply. Okay. All right, now let's talk about division of rational numbers. Now here we can model division of rational numbers by using the area model and the number line model. Like in this case here, how many 1/2s are there in 3 wholes? And in this case here, we take 3, divide that by 1/2, which will give you 6. So here's the illustration of that. Here we got 3 wholes. Each of the wholes will be split in half. How many of those halves are there in these 3 wholes? If you count them up, you'll get 1, 2, 3, 4, 5, 6. So in other words, there are 6 halves in 3 wholes. Or we can say how many 1/8s are there in 3/4. In other words, I'm doing 3/4 divided by 1/8. So 3 of the 4 pieces are shaded, and then we divide them up into that, because the whole is now in 8s. So now, how many of those 1/8s are there in those 3/4? Count those up, you'll see that it will be 6. There's 6 1/8 slices in 3/4. Okay. Another illustration of that would be how many 3/4 are in 7/8. Now here, in this case, you got the bar length of 3/4, and it's made up of 6 equal size pieces of length 1/8. Okay, so here's 7/8. But 3/4 is made up of 6 equal size pieces of 1/8, because if you think about it, 6/8 represents 3/4. And then there is at least one length of 3/4 in 7/8. As you can see right here, there's 1 left over. So if we put another bar length of 3/4 on the number line, you'll see that there will be 1 more of the 6 equal length segments needed to make 7/8. So if I do 7/8 divided by 3/4, that will be 7/6, which will be 1 1/6. Okay. Now those are just some illustrations of dividing rational numbers. Now let's look at the definition of dividing rational numbers. If we have A over B and C over D, they're any rational numbers, and C over D is not 0, then A over B divided by C over D will be equal to E over F if and only if E over F is the unique rational number, where C over D times E over F will give me back A over B. Okay. So now, when 2 fractions with the same denominator are divided, the result can be obtained by dividing the numerator of the first fraction by the numerator of the second. To divide fractions with different denominators, we rename the fractions so that the denominators are equal. Okay, so here A over B divided by C over D. Here, we will name the fractions as B over D here, and then probably they cross divide. A times D, that's this, and then B times C will be this. And then we use the reciprocal. When you divide fractions, you multiply by the reciprocal. So BC over BD, you take the reciprocal or the multiplicative inverse, so it'll be B over D over BC times AD over BD. Notice that the BD's divide out, you'll be left with AD over BC. Okay. And here's the algorithm for division of fractions. It's usually justified in middle grades by using the fundamental law of fractions, which is this. If A over B and C over D are any rational numbers where C over D does not equal to 0, then that means A over B divided by C over D would be equal to this. You bring over your A over B, but then you're going to multiply by the reciprocal of C over D, which is D over C. That's the algorithm that we should be familiar with when you're dividing fractions. You always multiply by the reciprocal of the second fraction. Or in other words, invert the second fraction and multiply. Let's look at this example here. Al saves pennies. He agrees to give 1/2 of his pennies to Bev if she would give 1/2 of what she got from Al to Carl. And if Carl, in turn, would give 1/2 of what he got from Bev to Danny. Bev, Carl, and Danny agreed, and Danny received 12 pennies. How many pennies did Al have initially? Okay. All right, so now let's take a look at this problem right here and see how this is going to work out. Okay, now here we're going to have to use the concept of working backwards. Okay, back in Math for Teachers 1, in problem solving, one of the techniques or one of the strategies for solving a problem would be to work backwards. This one, we need to work backwards because we're told that Danny received 12 pennies. Okay, she received 12 pennies. Now, Bev gave 1/2 of what she got from Carl to Danny. So we need to find out how many pennies Bev had initially. So that means the number of pennies that Danny got is 12. We need to divide that by 1/2, which is, of course, I'm going to put the 12 over 1 times the reciprocal of 1/2, which is 2 over 1. And then that means 24 over 1. 12 times 2, that's 24. 1 times 1 is 1. 24 over 1 would be 24. So Bev had 24 pennies. Now we need to find out how many pennies Carl had. Because Carl gave 1/2 of his pennies actually, and this should be Carl right here, by the way, I'm sorry, because Carl gave 1/2 of his pennies to Danny. And Bev gave 1/2 of her pennies to Carl. All right, so if Carl had 24 pennies, we're going to divide that by 1/2 and do the same thing. 24 over 1 times the reciprocal of 1/2, 2/1. So this is 48/1, which is 48. So Bev had 48 pennies. Now Al gave half of his pennies to Bev. So we need to find out how many pennies Al had initially. So if Bev had 48 pennies, we're going to divide that number by 1/2, which will be 48/1 times the reciprocal of 1/2 is 2/1. 48 times 2 is 96/1, which will be 96. So that means Al initially had 96 pennies. And that would make sense because you want to check to see if it does make sense, because he agreed to give half of his pennies to Bev. So half of 96 would be 48. That would mean that Bev will have to give half of what she got from Al to Carl. So Carl would have half of 48 would be 24, and then Carl would in turn give half of his pennies to Danny. Half of 24 is 12. Okay. All right, here's another example. Let's say we had a bookstore. A bookstore has a shelf that is 37.5 inches long. Each book that is to be placed on the shelf is 1 1/4 inch thick. How many books can be placed on the shelf? Well, in this case, this is a classic division problem. If the bookshelf is 37.5 inches long, each book is 1 1/4 inch thick. How many books can go on that shelf? So you got 37.5 divided by 1 1/4. So the first thing I would do there is convert each mixed number into an improper fraction. So here, if I do 2 times 37, that's going to be 74 plus 1 will be 75/2. So 37.5 will be 75/2 as an improper fraction divided by 1 1/4. Well, 4 times 1 would be 4 plus the 1 would be 5/4. And when we divide fractions, we always invert and multiply, if that's easy for you. So here we take 75/2 and we multiply by the reciprocal of 5/4, which would be 4/5. Now, if you want to, you can multiply numerator times numerator and then denominator times denominator to get your answer. Sometimes cross dividing helps as a short way of working the problem out, like the 2 and the 4. 2 goes into itself 1 time, and 2 goes into 4 2 times. I know 75 and 5 is divisible by 5. 5 goes into itself 1 time. 5 goes into 75 15 times. And then if I multiply 15 times 2, this will be 30 over 1 times 1, which will be 1. 30 divided by 1 will be 30. So that means here, 30 books can be placed on the shelf. Okay. All right, next we'll look at estimation and mental math with rational numbers. Estimation and mental math strategies that were developed with whole numbers can also be used with rational numbers, like in this example here. Let's say one used the rational numbers properties to compute the following products mentally, like 12 times 25 multiplied by 1/4. Okay. if I want to mentally compute that, let's do this. I'm going to group that 12 with the 1/4 because I know something about 12 and that 1/4 because 12 is divisible by 4 and then times 25. Well, 1/4 of 12, if you divide 4 into 12, that would go 3 times. So it'd be 3 times 25, which will give you 75. Okay. Sometimes it does have to show this. 4 goes into 12 3 times. Okay. Now in part B, we got 5 1/6 times 12. Well, what I can do here is this. Break up 5 1/6 as 5 plus 1/6. And then that'll be multiplied by 12. And then distribute the 12 over the 5 and the 1/6 by multiplication. So 12 times 5 will be 60. And then 1/6 of 12. This will be 60. If I divide 6 into 12, that will go 2 times. And then 2 times 1 will just be 2. 60 plus 2 is 62. And then for 4/5 times 20, I'm going to break the 4/5 as 4 times 1/5 of 20. 4 times and then 1/5 of 20. So I have 4 times 1/5 of 20, or do this, 5 goes into 20 4 times. And then 4 times 4 would be 16. Okay. So that's how we can use mental math to compute these numbers. All right, on the next page of your handout is estimating each of the following, like 3 1/4 times 7 8/9. Okay. Now, if I was to round to the nearest whole number, 3 1/4 would be something like this. 3 1/4 would round to 3. 7 8/9 would round to 8. Then if I multiply 3 times 8, that would be 24. Okay. So the approximate product for 3 1/4 times 7 8/9 would be about 24. And then in part B, we got 24 5/7 divided by 4 1/8. For a problem like that, I would use compatible numbers. Like something like this. If I kept 24 5/7 as 24, and then divide that by 4 1/8, that'd be 4. 24 divided by 4 would be approximately 6. Or I could do this. Round up 24 5/7 to 25, divided by, I'm going to have to round up 4 1/8. That would give me 5. 25 divided by 5 would be 5. Okay. Okay, here's a homework example dealing with estimation. Let's say we want to choose a number, and in the homework, they're going to give you a choice of numbers for the best approximation of each of the following. Like in part A, 4 1/3 times 6 2/3. So with that particular problem, what I would do there is round 4 1/3 to 4. And then 6 2/3, I can round that up to, let's say 7. And then 4 times 7 would be 28. So the approximate value for 4 1/3 times 6 2/3 will be 28. And then for 4 7/9 times 7 7 over 100, well, 4 7/9, I would round it up to 5 because 7/9 is close to 1 whole. So let's round it up to 5. 7 7 over 100, let's keep that as 7. So 5 times 7, that's 35. So for 4 7/9 times 7 and 7 over 100, the product of that would be approximately 35. Now for the 2 1/17 divided by 2 1/17 divided by 2 and 119. 2 1/19. Okay. Let's change that to a multiplication. We're dividing fractions. So here, 2 over 117 will be multiplied by the reciprocal of that. That'll be 119 over 2. And as you can see here, these 2's divide out. You'll be left with 119 over 117. And we just want to estimate that because that's a little bit more than 1. So the approximate number for that would be 1. Okay. All right, now let's talk about properties of exponents. In Math for Teachers 1, you were introduced to exponents and to some of the properties of exponents. Now, we're expanding this to include, in this case, negative numbers or negative integers. For any non-zero rational numbers, a and b, and any integers m and n, the following are true. A to the 0 is always going to be equal to 1. That means any non-zero number a to a 0 power is always going to be 1. And b, a to the negative m, we can write that as 1 over a to the positive m power. And then part C is this. If we multiply powers of the same base, we bring over that base and add the exponents here. A to the m times a to the n is going to be equal to the a to the m plus n power. Multiplying powers of the same base, you bring over that base, add your exponents. Part D is this. You're dividing powers of the same base. Bring over the base, subtract your exponents. Subtract the top minus the bottom. A to the m divided by a to the n is going to be a to the m minus n power. And then in part E, a to the m raised to the n, we're raising a power to a power. Bring the base over, multiply your exponents. It'll be a to the m times n. And then part F, a over b raised to the m power. The numerator will be to the power of m. The denominator will also be to the power of m. It'll be a to the m divided by b to the m. Now for G, you got a over b raised to a negative m power. The way that works is we take the reciprocal of a over b, which would be b over a, and it'll be raised to the positive m power. And then in part H, we're raising a product of two terms to a power. each one will be raised to that power. That A will be to the power of m, and B will be to the power of m. Okay, those are your 8 properties of exponents. So in this homework example number 7 that I have up here, we're going to write each of the following in simplest form using positive exponents in the final answer. So in this case here, for 5 to the negative 5 times 5 to the 7. Five to the negative 5 times 5 to the 7th power. In this case here, and that should be negative 7. In this case here, we're multiplying powers of the same base. We bring the base over and add the exponents. Negative 5 plus negative 7 is negative 12. But of course, we have to write it using positive exponents. Since 5 is to the negative 12 power, we use one of those properties by putting it as 1 over the base of 5 and make that 12 positive. So it'd be 1 over 5 to the 12th power. So in other words, for that one, I was using this rule here. A to a negative m power has to be 1 over a to the positive m. All right, part D. 5 to the 5th times 5 to the 7th. Here I'm raising up, well, here I'm multiplying powers of the same base. So I bring over the base of 5 and add 5 and 7 together, those exponents. That will be 12. So it'll be 5 to the 12th power. Now part C, I got 3 to the 15th power divided by 3 cubed. As you can see here, I'm dividing powers of the same base. So I bring over the base of 3, then I'm going to do 15 minus 3, which is 12. So 3 to the 15 divided by 3 cubed will be 3 to the 12th power. Now part D, 3 to the 15th divided by 3 to the negative 3rd power. Here I'm dividing powers of the same base, so I bring over the 3, and then I'm going to subtract 15 minus negative 3. 15 minus a negative 3 is the same as 15 plus 3, which is 18. So 3 to the 15th divided by 3 to the negative 3rd would be 3 to the 18th power. Okay. Part E, negative 7 raised to the negative 4th power. Okay. With this one, we're going to have to write this because of the negative exponent on the outside. We have to write that as 1 over negative 7 to the positive 4th power. We have to write it like that. Now, a negative to an even power is going to be positive. So this will end up being 1 over positive 7 to the 4th power, because negative raised to an even power is positive. In part F, a to the 6 divided by a to the negative 7. Here we're dividing powers of the same base, so we just bring the base over, subtract 6 minus negative 7. 6 minus -7 is the same as 6 plus 7, which is 13. So our final answer there will be a to the 13th power. Okay. And finally, this one has fractions raised to powers. Okay. So our final answer has to be using positive exponents here. So in part A, we got 1/2, and that's cubed, times 1/2 raised to the 6. And they want this in simplest form, by the way. So now we're multiplying powers of the same base, so we can add the exponents here. Our common base is the 1/2. We'll add 3 and 6 together, you're going to get 9. So it'd be 1/2 raised to the 9th power. Now, in this case here, we got a fraction raised to a power, so the numerator will be raised to the 9th power. The denominator will be to the 9th power. So that 1 will be to the 9th power, and the 2 will also be to the 9th power. Well, 1 to the 9th power, we can just simplify that as 1. But I'm going to leave that 2 to the 9th power as is. So the final answer there would be 1 to the 2/9, 1 over 2 to the 9th power. 1 over 2 to the 9th power. Now part B, 1/7 divided by 1/7 raised to the 7th divided by 1/7 raised to the 5th. Here we're dividing powers of the same base. So we bring over that base of 1/7, and we're going to do 7 minus 5. That will be 2. And then we raise the numerator and the denominator to the 2nd power. So the 1 will be to the 2nd, 7 will be to the 2nd. Well, 1 squared is 1. And that's good. In my math lab, they're going to want that as this. 1 over 7 squared. Now let's look at part C. Here we got 2/3 raised to the 7. And this time it's multiplied by 4/9 raised to the 3rd. Let's do something with that 4/9. I know something about 4/9. That's actually 2/3 times 2/3, which can be written as 2/3, and that's going to be squared. So here's what we're going to have. 2/3 raised to the 7, I'm just bringing that over, times, and I'm going to replace that 4/9 with what it's equal to. 2/3, and that's squared, but I still got that exponent of 3. I'm going to bring that over. Now for this part right here, I'm raising a power to a power so I can multiply the exponents. So let me bring that 2/3 to the 7th over, times 2/3 raised to the 2 times 3, which is 6. And now I'm multiplying powers of the same base. So that means I can bring the base over, which is 2/3, and add 7 and 6, which will give me 13. And that will be as far as I will go with that problem. So it'd be 2/3 raised to the 13th power. And finally, part D, 3/5 raised to the 7th divided by 3/5 raised to the 7th. Again, we're dividing powers of the same base, so that means we subtract our exponents. I'll bring the base over 3/5 7 minus 7 would be 0. But if you recall, any non-zero number to a power of 0 is automatically going to be 1. Okay. And if you think about this, 3/5 raised to the 7th divided by itself will give you 1 as the final answer. Okay, so that does conclude this video of section 6.3 dealing with multiplication, division, and estimation with rational numbers. Feel free to contact me, reach out to me if you have any questions about the material that's presented in this video or the material that's in the homework on my math lab.